Okay, so these are triangle coordinate proof notes and practice. So we've talked this year about doing T-column proofs. Today we're going to talk about a coordinate proof, which is another form of proof that we do in geometry. We call it a coordinate proof because it is on the coordinate plane. And there are some important formulas that you're going to be utilizing as we work through these coordinate proofs. And I'm just going to kind of briefly go through some of them. On slide 2 there, you've got a good resource page for you. Some things we've talked about. We've talked about with the slope. If the two slopes are the same, we know the lines are parallel. We know that if the slopes are opposite reciprocal, or if they multiply together to give you -1, that they are perpendicular. We've talked about the slope formula. Again, I know this was more of an algebra concept, but slope formula, y2 minus y1 over x2 minus x1. On this resource page, we're also giving you the midpoint formula, which you're probably not going to need that a whole lot for these triangle proofs. But when we get to quadrilaterals, you will. So x1 plus x2 over 2 and y1 plus y2 over 2. We'll most definitely need to know how to do the distance formula, and that is x2 minus x1 squared plus y1 or y2 minus y1 squared, all under the radical. And again, that's something that we did earlier in the semester. So again, I'm not asking you to memorize these formulas, but I am asking you to know how to use them as we go through this, and you'll see why here in just a minute. We're going to take a look at example 1 first. So example 1, here's what it says. It says, given the triangle with vertices A 4, -1, B 5, 6, and C 1, 3, show that triangle ABC is an isosceles right triangle. Now, this problem is kind of putting everything together that you're going to have to be able to do. They won't all be this complex. And I think this is a good example for us. First of all, to prove that the triangle is isosceles, what do we have to show about the picture? Okay, so we have to show that two sides are the same length or that they're congruent. So very good, Lila. So as we're doing that, in order for us to show that two sides are the same, we're going to utilize the distance formula. So what I'm going to do here, it appears to me, and hopefully it appears to you, that the length of CB and the length of AC appear to me to be about the same. So I'm going to start with those two sides. So we're going to do the distance formula. So the distance formula, we're going to do 5 minus 1 squared plus 6 minus 3 squared. And we're going to go ahead then and simplify that. Well, 5 minus 1 is 4. 4 squared is 16. 6 minus 3 squared, that's 3 squared, which is 9. So we know that that's 16 plus 9 is 25. And the square root of 25 would be 5. Now we're going to do the same thing for AC. So I'm going to do 4 minus 1 squared plus -1 minus 3 squared. Well, 4 minus 1 is 3. 3 squared is 9. -1 minus 3 is -4. -4 squared is 16. So once again, you can see I'm getting the square root of 25, which is 5. Now, by what we've showed, we've now showed that this is isosceles. Both these sides are 5. But what we've not shown yet is we've not showed that the triangle is a right triangle. So in order for us to show that it's a right triangle, we have to pay close attention to what are the slopes of the line. Again, if we can show that 2 of the lines are perpendicular based on their slopes, then we can prove that it's a right triangle. So what I'm going to do in this picture is I'm going to go ahead and I'm going to find the slope of BC, and I'm going to find the slope of AC. Now I can do this one of 2 ways. I can do the formula. That's what I'm going to do for the first one. If I do the formula, I'm going to do y2 minus y1 over x2 minus x1. So if I do 6 minus 3 over 5 minus 1, that gives me a slope of 3 over 4. Now, for AC, something else you could do is, if you don't want to use the formula, since we've already have the grid here, is you could use your counting method. So if I start at point A, I go up 1, 2, 3, 4. So that's a vertical change of 4. And I'm going to go left 1, 2, 3. That's a horizontal change of -3. Hopefully you notice when I'm looking at the 2 slopes, 3/4 and -4/3, those are opposite reciprocal slopes. So therefore, BC and AC are perpendicular. Now, the last part of this is your explanation. Sure, we've showed now mathematically that this is an isosceles right triangle. But to complete our proof, we need to make sure that we explain why it's an isosceles right triangle. Okay, so I'm gonna write a sentence here. I'm gonna say triangle ABC is an isosceles right triangle because sides CB and AC are congruent and BC is perpendicular to AC. And that would complete your proof then. Again, I was explaining this to the other class. If I were grading this, this would be a 6-point problem. It'd be 1 point for each of your distances, 1 point for each of your slopes, and then 2 points for your explanation. Now, there are going to be some of these problems where they're not going to give you the picture, and that might be another point in your, you plotting the points onto your graph. On this one, they actually gave that to you, so that wouldn't be something I'd give you points for. Okay? Anybody have any questions? Prove that the polygon with coordinates 1, 1, 4, 5, and 4, 1 is a right triangle. So step 1, I want you to go ahead right now and go ahead and plot your points. And then try right now on your own to see if you can show it's a right triangle. Okay, let's go ahead and go through this. Hopefully, as you're looking at this, to prove that this is a right triangle, we have to look at the slopes of two of our sides. And hopefully, as you look at this angle down here looks like a right angle, and it is a right angle, but we have to show that. So we're going to find the slope of AC. And we're going to find the slope of BC. So slope of AC, horizontal line. You really don't even need to do our formula for that because we know a horizontal line has a slope of 0. Same thing with BC. It's a vertical line. We know the slope of a vertical line is undefined. So we know that 0 and undefined are opposite reciprocals. 0 has 0 on the top of the fraction. Undefined has 0 on the bottom of the fraction. So we can now use our information to state that we can say triangle ABC is a right triangle because AC and BC are perpendicular. And if you want to use the perpendicular symbol, you could.